So let's do another example. So let's say we have this transfer function. So while doing the exact plot for comparison, so let's first do an exact plot. So this will be the exact plot for the magnitude of this transfer function, and this will be the phase mode plot. Now let's superimpose the straight line mode plots. Okay, for the magnitude, first we need to convert this transfer function into its standard form. And we notice that there are three factors. We have a simple zero, we have a pole at the origin represented by 1 over j omega, and simple pole. Okay, so we need to plot the straight line mode plots of these three factors. For the simple, or for the pole at the origin, well, we know that this makes a negative slope of negative 20 dB per decade, and it passes through omega equals 1 radians per second with a value of 0 dB. Okay, so this is the straight line mode plot of the pole at the origin. Next, we plot the simple 0, 1 plus j omega slash 2. So here we identify the 2 radians per second. Before that frequency, the value should be 0 dB, and after that it should increase with a slope of 20 dB per decade. And then for the simple pole, we also identify the location of 10. So here's the 10. So before that it is 0 dB, and after that it makes a negative slope of negative 20 dB per decade. So we combine them. So you'll notice that um, before 2 radians per second, the combined plot should follow the green line. Then after 2, the slope of the green line will be offsetted by the slope of the violet line. So after 2 radians per second, it should be a flat line up to 10 radians per second, after which it should follow the slope of the pink line. So this is the plot. So notice that between 2 radians per second and 10 radians per second, the value is not actually 0, it is slightly lesser than 0 because it became flat after 2 radians per second. So that is the plot. So between 2 and 10, this is not actually 0. Now for the angle, first we plot the pole at the origin. So based on our reference, this is negative 90 degrees. For the simple 0, so again we locate point 2. Before that it should be 0 dB. After that it should make a 45 degrees per decade slope positive up to 20, so 10 times 2. After 20 it should be flat. For the simple pole, we locate 1 radians per second. So before that should be 0. After that, it should make a negative 45 degrees per decade slope up to 10 times 10, which is 100, after which it will be flat. Then we combine the plots of the three straight line Bode plots. So we get like this. So before point 2, all lines are flat. So the phase angle should follow the phase angle of the green line. After point 2 radians per second, it should follow the slope of the violet line up to 1 radians per second, after which the pink and the violet line slopes offset each other, so it should be a flat line up to 20 radians per second, after which it should follow the slope of the pink line up to 100 radians per second, after which all lines are again flat, so it should follow the value of the green line. Okay, so that would be the result of the phase straight line Bode plot.